My name is Tom Levine, Cornerstone's tech guru, and today we'll be covering what exactly the internet is, how to hook up your own internet if you're trying to save a buck, and believe it or not, a little bit of the history of the internet and what makes it so useful today. The internet's been around for quite some time, actually, and believe it or not, it's been in use in commercial applications since around the 90s. Believe it or not, Skype actually founded in 2003, and that was the first video chat service online. So we've been using the internet basically all the time in business since the early 90s. But when we talk about the internet, specifically what we're talking about is networking and what makes up networks. All networks are sets of interconnected devices. They were developed originally by the military with help from specific scientific facilities and other foundations. Connections were made between computers using wired connections. We refer to these wired connections today as Ethernet connections. But they are used to connect local computers to each other. Then from there, those computers get connected to different facilities and other groups of facilities, etc., so on and so forth. That sort of goes into how the internet works today as well. So it's basically the same thing. It's just a bunch of computers that are talking to each other through networks. The internet is a very large network, however. It spans the globe. And it actually opened up to people for commercial use, like I said before, in the early 90s. But that gets into some more of the jargon about networks. Honestly, 90% of the time, if you're talking about how networks are set up, you won't be using these words. This is just some common networking jargon. If you're talking to your service provider or a technician, they might use some of these words, so helps to be prepared. First up is clients. Clients are the physical devices that access your network. So that would be like the device you're using right now to watch Tech Tuesday, for example, or your work computer at work, or your tablet or your phone. Clients are the individual devices that access the network. Access points and nodes. These are points that a computer or other device uses to gain access to networks directly. They are also called nodes, so access points are nodes. Typically, these are your wireless routers or your different types of bridges as well, can also be hubs, or nodes, I guess, I'm sorry. Hubs are where those data points and nodes collect to transfer data from. Then bridges are pieces of equipment used to relay connecting devices. So basically think of the bridge as the connection between your bigger network at large and your local network. Often these are called modems. Sometimes modems and routers can be two in one. Router being your access point or direct node typically, and your modem being the hub or a bridge used in these sorts of connections. Please forgive me if that got a little jargon heavy, but we're going to explain it in English here in a second as well. Then we also have wireless access points, which are just nodes that act wirelessly, and wireless distribution systems, which are a collection of wireless nodes that use sort of, they can be referenced collectively as a wireless network. Either way, there are two different types of network modes and formats. The first, which we'll be talking about mostly today, is infrastructure mode. An infrastructure mode is a network relying on a bridge or relay components that connect other devices together. Typically, this involves physical pieces of equipment that don't change location, but the bridge is used to regulate the communication happening within and on a network. So it's the, think of it more as the gatekeeper, I guess, in typical communications. It's the sort of the bodyguard standing at your door. That way you have some sort of protection against just the rest of the internet coming through. Then there's also ad hoc modes, which are typically useful in connecting together devices at short range with no sort of bridge or relay component in between. It's not really used very often when we refer to the internet today, but typically it will be useful in short distance communications. These are things like connecting your phone to a wireless speaker and those sorts of little random communication things that devices do to talk to each other. There's not really any need to establish a formal network mode of communication, hence the term ad hoc. So it's useful to think about, but it's not really useful when thinking about the internet as a whole. Then in addition to that, we have different other network types. There is peer-to-peer ad hoc. We mentioned ad hoc networks before, but peer-to-peer ad hoc is pretty exclusive to 10 feet maximum ranges. It's used to connect two devices together without using a bridge device or a modem router. Then there's the local area network, or LAN. This is a network of devices that all operates within the same circuit of communicating devices without any reference to any other outside circuits. This would mean any sort of device locally connected together, like in your house over your Wi-Fi. That makes up your local area connection. It's commonly used for households and buildings, but it can also be used to connect wider areas. I believe the largest local area connection that I've personally connected to was UC's Wi-Fi. That is a collection of wireless points that are all, connected together. It's all UC Wi-Fi, but they form a wireless distribution network, which makes up the rest of the UC local area network. So it can get a little complicated, I guess. But anyway, outside of your local area networks are the wide area networks. To put it into perspective, the largest local area network might take up the range of a city block. The largest wide area network could span a whole state or a nation. So wide area networks are very large networks of local area networks, essentially. A large network, it spans multiple local networks. That's basic definition. Typically, these are the people you'd reach out to in order to gain access to the internet. If you're talking Cincinnati area, this would be your Cincinnati Bell, or your Spectrum. Your internet service provider is your wide area network. So what's the difference then between Wi-Fi and the internet? The difference is scale. Wi-Fi is a wireless LAN connection, or WLAN, meaning it's just a local connection. It uses an infrastructure mode of communication. You use this network to communicate information between devices using radio waves for your wireless signal, or through wires using Ethernet ports. That's your Cat5 or Cat6 cable. Additionally, it communicates information to other devices using radio waves. It's also purely used for local communication between devices, and that's the important point. Wi-Fi or a wireless connection like that is typically only referred to for local communication between devices. Yes, it can connect you to the internet at large using a modem, but typically Wi-Fi is the part of that step that's very local. Additionally, you have the internet as a whole. The internet is just a large group of interconnecting wide area connections. It's an infrastructure mode of communication, and mainly it uses hardline communications via wires underground or satellite communications to transfer large amounts of information between large numbers of computers. Typically, it's only considered on this level by ISPs or other research institutions. But the internet is used to collectively refer to all of these connections. This could be connections between cities, states, countries, or even fiber optic cable that's going under the ocean right now, connecting different nations across oceans. So all that said, that's sort of what the internet is as a whole, but that's not really where we interact with it on a day-to-day basis. Typically, the highest up you'll ever go into the hierarchy of networks is a WAN, or a wide area network address. That's the ID that your modem uses, identifying which node it is on your ISP's network. This is, basically exactly what your carrier uses to identify your devices connecting to your connection. It is probably one of the most important IDs that no one ever remembers, but it's typically printed on your router. There's also the Media Access Control ID or address. This is the ID used by your router to identify itself within the local network. So whereas the WAN ID tells your device apart on the large network, the MAC ID tells it apart on the local network. So a WAN ID would be like my router telling the rest of the routers on Spectrum's network that it exists and it is this specific address. The MAC ID says that it exists within my apartment's set of interconnected devices. So every different one of my devices, my Roku, for example, or my computer, or even my phone when I have Wi-Fi turned on, all roll up to the media control ID, that MAC ID, and then that MAC ID then broadcasts using the WAN ID out to the rest of the network, if that makes sense. Then there's a IP address. We go back. That's your Internet Protocol address, and that is the ID assigned to your individual device within the Internet as a whole. So that's like, instead of the MAC ID on your router, this would be the actual ID that corresponds to your device when seen on the Internet. So this would be my phone or the computer I'm giving this presentation from now. Then you have to think about the hardware involved as well. The hardware involved, as I've mentioned before, is typically just a modem, a router, or a two-in-one, which is both. The modem acts as the hub for your local area network. It connects all of your devices to the ISP's area network. So it's basically the connection from your wide area network into your local area network, your LAN. Your router is your access point for your local area network. So it's what all of your devices have to connect to then connect to the modem that then gets out to the wide area network or your internet as a whole. They do actually make these as two-in-ones now, meaning they have devices that act as a combination modem-router all at the same time. We're going to be showing some pictures of these different devices here in a minute, so hopefully that'll help you out if you're trying to differentiate what's what. But typically, modem router two-in-ones are what you'll be using if you're renting from your ISP, and a lot of people are. But before we get into why you would want to even rent or set it up on your own, why would you want to buy your own hardware? Hardware used to actually be pretty expensive. So a modem and router alone could cost maybe $600 if you're just trying to get set up. At least that's how it used to be. Nowadays, that's can't be farther from the truth. If you're renting a two-in-one from your ISP, modem and router, if you're just trying to buy them, normally cost about $100 to $150. At least that's for a normal bottom line modem router. That's about all anyone normally ever really needs, because typically you don't get a good choice on what speed you get for your internet, but we'll get into that here in a second. Cincinnati Bell nowadays charges an $8.99 monthly fee for renting a modem router. This totals up to $107.88 a year. So you could do that and pay them yearly every year until you switch networks or decide to go out and buy your own stuff and just spend money. Or you could spend close to about $100, $150, set it up yourself, and never have to pay those fees. Additionally, Spectrum used to charge close to $64 a month to rent one of these things, which is just ridiculous considering how cheap they are. In the latter half of 2019, however, I do have to say Spectrum did cut these fees. However, they still tack on, for some reason, a $5 Wi-Fi fee if you're using a wireless router. If you have an older plan, you may even still be paying the $64 rental fee. So if you add it up, you know, the $5 monthly cost still adds up to $60 a year, but that's the cost of a less sophisticated router anyway. So if you're just renting a modem from them and you're not using the Wi-Fi capabilities, just get your own wireless router, and then you don't have to pay the fee anyway. The standalone cost for a wireless router can be between $40 and $80 typically, 60 is just a good middle ground estimate. But anyway, in the older of the two cases, that would mean that if you just bought your own equipment, you would have been saving $768, excuse me, yearly, just by getting your own modem router combo set up. Over 5 years, that would have been $3,690, just as a conservative estimate of how much you would have been spending. So that's why I would have recommended getting your own. Nowadays, it's a lot more affordable, just because the word kind of got out and people started setting up their own Wi-Fi and routers. But you do have to consider some things if you're thinking of going this route and setting up all of your own networking. It is very easy. Just make sure you have the correct cable. Make sure you have the correct hardware, which would be a modem-router and a router, or just a modem and a router. So as long as you have those two pieces of equipment or a two-in-one, you're going to be fine. I would make sure you call and reach out to your ISP before trying to set this stuff up, because believe it or not, some ISP networks do not work with other pieces of hardware. So get your modem first, or your modem-router two-in-one, and I would try to select that by talking to your ISP. So pick one out, make sure you think you know what you're going to buy, call your ISP, ask them if that will work on their network. If they say yes, buy it, and then connect up to the network. Then there are also a few other things you need to consider. First, do you want to mainly use Wi-Fi, or are you going to use wired connections? This matters because there are some routers that are just wireless. They don't do wired connections. Personally, I prefer to use a wired connection if I'm trying to do webinars. Just this webinar right now is also being done over a wired connection to my router right now. And I think that's a little bit easier. It has fewer interruptions on the network, so you hear a little less static. Also, I think it makes for clearer sound all around. But that's just when I'm streaming or when I'm giving wireless, networking talks. There are other reasons why you would want to use a hardwired connection, mainly the faster speed. Typically, these sort of wired connections are measured in gigabits per second. Gigabits per second involves kind of the metric system, and we'll get into what the difference is here in a second under bandwidth limits. But basically, the higher the number, the better, and gigabits are more than megabits. So when you're talking bandwidth speed, you want that to be the highest total value under gigabits, or if it's giving it to you in megabits, you're going to want it to be as close to 1,000 as possible. Gigabit internet is sort of new, so it's rare that you'll probably be encountering it on a private market. It's more for like business class internet these days, but the higher the number, the better the internet connection. And there are 1,000 megabits in a gigabit. Typically, megabits are what the wireless connection speeds will be rated in. So your Wi-Fi speed will probably be in megabits. But also, sorry to jump around, the final little connection thing you need to check is you'll need to make sure that whatever you're using to connect into your wall from your cable company can connect into your modem. There are typically two different types of connections used here. There's coaxial cable, which is just your cable line from your old TV. That will hook into a coaxial hookup, just like you're hooking up cable on the back of your router, well, back of your modem, I apologize. If you do this on the back of your modem, then that's probably the connection you'll have. The other option is to use phone line, and this is when you get into your DHL hookups or your old landline hookups. These used to be considered excessively slow, and they still are, but sometimes that's all you've got. And honestly, the phone line connections now are a lot more open because so many different people use wireless networks. It's a lot faster than it used to be. Still not as fast as hardline connections, but it's faster than you would think it would have been, at least. For setting up your own Wi-Fi, however, you need the required hardware. Like I said, that's a modem router or a 2-in-1, coaxial or phone line cable, depending on what your provider uses. Ethernet cable, this is typically Cat 6 or 7 cable. For newer gigabit speeds, you will absolutely need a Cat 7, probably. The Cat ratings on the cables specify the types of wired connections that they're certified to carry. This is typically different speed and different bandwidth limits. Any Cat cable works for hooking up two devices through wired internet connections, but the higher the number, the faster the connection, the higher the quality of the connection. That's typical rule of thumb. Cat 6s and 7s are what we're using now, and they can support up to 10 gigabits per second. I don't recommend getting higher rated cables than that unless you're using sort of like an industry grade server or like real specialized equipment. To give you a point of comparison though, standard Cat 6 speed is the same as standard Cat 7 speed. So that's supporting up to 10 gigabits per second. It just has a lower bandwidth by more than half. So whereas one of the Cat 6 cables could maybe support one device at the 10 gigabit speeds, if it had multiple things connected to it, that speed would tank pretty quickly. It would get a lot slower. Whereas the Cat 7s likely would not, because they have a wider bandwidth, which means more devices can access it at once and can transfer data along that cable. Anyway, how to set it up. You're going to put your coaxial cable on your internet access point. Then you're going to attach the other end of the cable to your modem. If you have a separate router, you attach it to your modem with the Ethernet cable. That's about it. I know that seems pretty easy. Here, we'll get back to where we were. Seems pretty easy, pretty summarized, well, quick actually. But for those of you who learn visually like me, hopefully this puts it into a bit of a better perspective. That shiny little dongle looking thing under the yellow rectangle on the modem router combo on the left, that is the coaxial in jack. That's the port that you'll be using to connect your cable line into your modem. This box you're seeing on the left is a modem router combo, but most modems look about the same as that actually. Those connections in the yellow box on the left, those are your Cat connections. So that's where you would plug in your Ethernet cable as well. These are typically numbered 1, 2, 3, and 4, depending on what type of router or modem you use for that. But basically what they do is those are your internet out connections. So that's where you would connect in your wireless routers, or you would wire it in your devices. So this is what you would connect your physical cable lines to, right over here in the yellow box. But that's just if you're using a modem. If you're using a standalone router, or you've already got your modem hooked up and you're trying to connect your router in, you would use one of those Cat 6 cables to connect one of the yellow rectangle connections. Doesn't matter which one. I like to start with 1 and go to 4, but honestly the numbers are just there for labeling. Connect one of those from the yellow box into the gray box in the router standalone picture on the right. The gray one will typically either be spaced far away from the other LAN out connections, but that's basically the internet in. So that's what connects your router to your modem. If you're using a 2-in-1, you won't have to connect the router and your modem, but typically you can get better deals if you buy them as 2 separate pieces of equipment. One thing to look at though when you're doing that is the speed of both of the devices. Make sure that the megabit per second you're seeing, or the gigabit per second, or the gigabit per second connection that you're seeing, match or are about the same. If you get to vastly different devices rated for vastly different speeds, the chances that you'll have a bottleneck on your internet speed kind of abound. Basically what that means is you're only as fast as your slowest connection, which is why I was mentioning the Cat7 versus the Cat6 cable. Cat7 is going to be just as fast if you're just using one device, but if you're trying to connect a lot of devices together across large networks, you're going to want to use the Cat7 cable for sure, just for the wider bandwidth. Yeah, the more devices you have connected, the wider the bandwidth you're going to need. So honestly, if I haven't bought a new cable yet and I was going to go and hook up my internet today, I'd probably want to just get Cat7 cable. Cat6 cable is useful if you're trying to save the buck. Anyway, there are some more things that you can do with wireless routers as well that you can't really do so much with a wired connection. First of which being you can rename your routers and also change your password for connecting to your secure Wi-Fi. This is more for home networks than for anything else. Let's see if we're frozen here. Nope, it looks like it just switched. Sorry about the delay there. But anyway, you will need your router's IP address in order to change things about your wireless connections. In order to find this, typically it's in a manual that comes with your router or with your router-modem combo device. But if it's not in your manual, you can also check the side of your device. Typically it has it printed there. But if you also don't see it printed there, you can actually find it through your computer pretty easy. The picture above is of the Network and Sharing Center from Windows 7. However, most people have already moved on to Windows 10 if you're using Windows, and if you're using a Mac, believe it or not, finding this setting is even easier. But using any web browser, basically, you're going to put your IP address in there. To find this in Windows 7, you're going to click on that local area connection section in blue, just to highlight this for you real quick. That would be this area right here that I just circled. Anyway, once we do that and click there, typically a menu will pop up. If you go under that menu, just keep scrolling through for the network properties for IP, lowercase b, 4, under address. That's the IP address of your modem-router or your router in general. And if you go there in any internet browser, then you should be able to edit your device's name, edit the password you have to connect, and anything else you need to about your internet connection to personalize it or make it a little more secure maybe and change the password. In Windows 10, in order to access this, all you do is hit the Start button and go to Network Status. Just type it and it'll be the first option. Then you can go to Change Network Properties and it'll be the same thing under that IPv4 address. Also, if you're doing this in an Apple product or in a Macintosh, all you do, I believe, is go to System Preferences, then Network, and it just displays the IP address from there. So you type that IP address into any web browser, and it'll pull up your router on the network, so long as you're already connected to that network. And then that would be how you edit your connections. The final step, however, is to call your ISP. And this is what I mentioned to do before you actually bought your router modem combo, just to make sure that your devices work within your network at least. Things to have handy prior to calling your service provider is the WAN or WAN ID of your modem, and also the serial number of your modem. Those are the two things they're going to ask you about when you call in and you're trying to set up your connection, because those are the two things they have to record in order to give your modem access to your network. Once they have those two pieces of information verified, it should kind of fix everything and your internet should be all set up. You should just be able to connect on any of your devices straight out to any sort of wide area connection you've just set up. And that should be it. Once you call them, you give them the IDs, they'll tell you when they have everything set up, and you're done. You shouldn't have to pay them any more wireless access fees or any sort of rental fee on your modem or your router. And then you can start saving money. The last thing I will mention, though, is the limits on wireless networks. Speed is the trade-off for ease, I guess, is what I'd always say for wireless networks versus wired Ethernet ports. Wired connection rate is constant and matches exactly what you're going to pay for from your ISP, or at least it should. This is assuming that your router can match the same speed. Wireless network speed varies, however. This is due to atmospheric interference, how close you are to your signal source or your router, the different thickness and different types of walls that could be blocking your radio signal, the one between your router and your device, as well as the distance, the physical distance between the two. Average data transfer speed for a wireless network is about 30 to 60% of what your cable provider or your ISP is saying they are giving you. And that's typically due to things they can't even control. Also, the more devices you have on a network, the slower the speed in both cases. So if you're like me, working from home and curious as to why your internet connection is so slow if you're not physically wired in, that's why. It's a lot of atmospheric interference and just sort of the limits of technology as a whole. But anyway, what's coming up as far as Cornerstone webinars go? Tomorrow we have the individual corner and how to increase your revenue with ancillary sales. This is going to be given by Jeff Beglin and special guests over at IHC. We also have on April 28th the Build Your Brand Eye Contact Email Marketing Walkthrough. I think this will be very useful, especially to anyone looking to expand their brand's reach through email marketing. I think Eye Contact is a wonderful company, and I think you're going to love the walkthrough. Also, which web browser is right for you? Now that we've talked about how to edit our network connection settings, I think it's about time to talk about how to interact with the internet. So that's kind of what we'll be talking about and more in which web browser is right for you. That'll be on May 5th. If anyone has any questions, please feel free to put them in the question box there and I will answer them now. If you have any other questions related to any of our other Tech Tuesdays, I'm happy to answer those as well now also. So if you have any questions, please feel free to type them in the chat. Otherwise, have an excellent day and thank you for stopping by. These are our references as well for part of this presentation, if you're so inclined. First question is, can we receive a copy of the PowerPoint? Yes, absolutely. If you request that in the questions right now, I'd be happy to send you one. Also, all of these are fully recorded and uploaded to our websites. So if you go to the www.crnstone.com website and go under our, I believe it is our sharing center and our library, you can get to a recording of all these webinars. But yes, I will gladly send you out a copy of the PowerPoint. All right. I'm not seeing any other questions coming through, so I will go ahead and stop it here. But thanks again for coming out, and I will send out an email to those who requested it with the PowerPoint. So thank you very much, and have a wonderful day.